The next topic is basic properties of charges. Basic properties of charges, as you can see here, there are what are the some of the important basic properties of charges are. The first one is the like charge repel each other, unlike charge attract each other. Then the second is the additivity of electric charge, conservation of electric charge, quantization of electric charge, invariance of electric charge. So let's see one by one what are these properties. Like charges repel each other, unlike charges attract each other. See here, these two charges, these are positively charged bodies, and due to which a force, repulsive force, start working between these two charges. In the same way, if the charges are negative, that means if they are again like charges, then they are a repulsive force start acting between them, due to which they are repelled, as you can see here and here. If both the bodies are neutral, then no force is acting, and hence they neither repel nor attract each other. But in case of one of the body is positively charged and another is negative, that means if they are oppositely charged, or the charge is unlike charges, then they start attracting each other. Again, the electrostatic force acting between these two charges, but it is of attractive in nature. So the first property is like charges repel each other, unlike charges attract each other. The next property is additivity of electric charge. Now this is again very important property, additivity. Additivity of electric charge means total charge in a body is algebraic sum of all the charge in a body. Say for example, suppose this is a body which is represented here with a yellow color sphere, and if it has three different charges, Q1, Q2 and Q3, then the total charge Q is equal to, it is algebraic sum of all the charges. Say for example, suppose this is the body and it has three area, and suppose this area has 4 coulomb charge, this area has -3 coulomb charge, this area has 8 coulomb charge, then the total charge on this body, that is total charge on this body, is the algebraic sum of all the charges, 4c minus 3c plus 8c, that comes out to be 9c, 9 coulomb charge. So this is the additivity of electric charge. Electric charge can be added, can be subtracted also, because if the charge are of opposite sign, then they are subtracted like this here, and they are otherwise they can be added also. So the additivity of electric charge, total charge in a body is algebraic sum of all the charges in a body. Now the next property is conservation of electric charge. This is again very important property. And what is the conservation of electric charge? The statement is very clear: charge cannot be created, cannot be destroyed, it can be transferred from one body to another body. So this is the conservation of electric charge. As you can see here, this body has 4 electrons, and this is uncharged body, and when we touch this body with the uncharged body, then this body has charge -2e, that is 2 electron, and 2 electrons come here in this uncharged body. So if we add both the electron, then it becomes -4e, which is the initial charge of the body. Initially the body contained -4 electron, and then 2 electron remain here, 2 electron comes to the another body. Then if we sum up all these charges, then again final position we can find out here. Total electron is again 4, and here also total electron, if we sum the charge on this and on this, then again here also we can find out that the 4 electron is here, and since here no charge, so it is 0. So there is 4 electron, and here you can see this is 2 electron, and this is also 2 electron here, so if we add both the electron, then it is also 4 electron. And now suppose this is a question for you. If this is the body, and this is the system actually, and it has, suppose this system consists of 3 different sphere A, B and C, and suppose at t is equal to 0, the condition of this system is the body A contain 4 coulomb charge, body B contain minus 2 coulomb charge, and body C contain 6 coulomb charge. And after some time, the same system at t is equal to 4 second, t is equal to 4 second, the condition is the body A, this is body B, and this is body C. So suppose this contain 8 coulomb charge and this contain 4 coulomb charge, then find the charge on this body. So we can easily find out with the help of conservation of electric charge. The total sum of all the charges here and here remains same. So if we find out the total sum here, so 4C minus 2C plus 6C, so the total charge is 4C minus 2C plus 6C, so it may come out to be 8C, comes out to be 8C. And then here in the second condition we can see that the charge body A contain, if the total charge on here is 8C, so it here in the second case after t is equal to 4 second, the total charge here also will be the same. So 8C plus 4C plus x is equal to 8C. So with the help of this equation we can easily find out the charge on the value of x, which is equal to minus 4C. So we can easily find out with the help of conservation of electric charge how many charges are there in a body after some time. So this is the conservation of electric charge. Charge cannot be created, cannot be destroyed. It can be transferred from one body to another body.